In question 2, we are looking at discrete random variables, and we've got a random variable x which can only take the values 1, 2, or 3. And the key thing to recognize here is that we are looking at the cumulative distribution function. So what that means is that if we look at f of 3, for instance, this is going to give us the probability that x takes the value of either 1 or 2 or 3. And since those are the only three things that can happen, we know that the value of f of 3 will equal 1. So since we know that f of 3 equals 1, we can find the value of f of 3 according to the formula, which is going to be, if we want f of 3, it's going to be 3 cubed plus k over 40, and we know that that will be equal to 1, because there are only three values, 1, 2, or 3, so the probability that that x is 1, 2, or 3 must be 1. So we take that, set it equal to 1, and then we've just got a simple equation, so we're going to have 27 plus k is equal to 40. So we can just solve that to get k equals 13. In part B then, we don't want the cumulative distribution function, we want the probability distribution function for x. So we are going to need to have the values of x, so here that's going to be 1, 2, and 3, and the probability that x takes each of these particular values. So the first part is fairly straightforward because we should be able to recognise that f of 1 just represents the probability that x is equal to 1, because 1 is the first piece of data, so the individual probability that x equals 1 will also be the same as the cumulative distribution function. So we're just going to substitute in here 1 cubed, which is 1, plus the value of k, which we said is 13, and set that over 40. So f of 1, therefore, is going to be 14 over 40. Now, it's the second one that's a little bit trickier. If we were to look at f of 2, we are going to recognise, hopefully, that f of 2 represents the probability that x is either equal to 1 or the probability that x is equal to 2. So this is what we want to find. So essentially, the probability that x is equal to 2 is going to be equal to f of 2 minus the probability that x is equal to 1. So the probability that to find f of 2, we're going to do 2 cubed, which is going to be 8 plus 13 all over 40. That's just substituting 2 into here. So that is going to give us 21 over 40. We then need to subtract the probability that x equals 1, which we found here, which is 14 over 40. So that's going to give us the probability that x is equal to 2 is equal to 7 over 40, which is going to go in here. And then we should recognise that the sum of these individual probabilities must equal to 1, so we can just do, to find the probability that x equals 3, we can just do 1 minus 14 over 40 minus 7 over 40, which is going to give us the answer of 19 over 40. For the final part, then, we're given the variance of x equals 259 over 320. We're asked to find the exact value of the variance of 4x minus 5. Now, what this number here, 4, is going to do is act to increase the, because we're multiplying all the values of x by 4, that's going to increase the standard deviation by a factor of 4, and therefore, since the variance is the square of the standard deviation, that is going to have the effect of increasing the variance by a factor of 4 squared. So therefore, we need to take 4 squared, or 16, as the factor, and multiply that by the variance here, 259 over 320, and we should see that that's going to cancel out to give us a final exact value of 259 over 20.